class 12. Today we are going to discuss example 3.5, in which a network is given to us, in which we have a battery applied having 16 volt and internal resistance 1 ohm. Then we have to find the equivalent resistance of this circuit network, and we have to also find the current passing through each arm of the resistance, and also find the potential drop across point AB, across point BC, and across point CD. So now we shall be discussing it one by one. Here in this circuit we have to find the equivalent resistance. So what we do is we find the equivalent value of parallel combination of 4 ohm and 4 ohm connected between A and B, and that becomes 1 by 4 plus 1 by 4 becomes 2 by 4 is the reciprocal of equivalent, and therefore R parallel is equal to 4 by 2, that is 2 ohm. You all know the relation for computing the parallel combination, equivalent resistance of the parallel combination of the resistances. We use the formula 1 by R, R1 is equal to 1 by R2 plus R3, etc. And similarly for series combination we have R is equal to R1 plus R2. We all know about it. So we are using this relation over here, and then we find the equivalent resistance of the two parallel resistances 12 ohm and 6 ohm connected in parallel between the point C and D, and that becomes equal to, in the same way you are using the same relation, 1 by Rp is equal to 1 by R1 plus 1 by R2, and then find the value of equivalent parallel combination, resistance of parallel combination. We get it equal to the equivalent resistance of 12 and 6 ohm is equal to 4 ohm. So that is how we have found the equivalent resistance of these two parallel combinations between AB and CD, and therefore the total resistance now R is in series, and so we calculate it by adding them. So for between A and B we have 2 ohm. So 2 between BC we have 1 ohm, so 2 plus 1, that is 3, and between CD we have 4 ohm, so 3 plus 4 becomes 7 ohm, and that added with 1 ohm becomes 8 ohm, and then we add the internal resistance of the cell, which is 1 ohm, so that is, so this is the equivalent resistance of, means here 1 ohm is representing the internal resistance of the cell. So the total equivalent resistance of the network having 2 ohm, 4 ohm and 1 ohm in series becomes 7 ohm altogether. So this is how we got the equivalent resistance of the combination. Now we have to find the total current drawn from the cell by the circuit. So you have the we have the total resistance. This is the total resistance. Sorry, I am sorry for this. This is the total resistance is only 7 ohm, but when we include the internal resistance it becomes 8 ohm, so that the total resistance will be plus 1 ohm of internal resistance. So that becomes the total resistance becomes 8 ohm equivalently, and then 16 volt supply divided by 8 ohm becomes 2 ampere. That is the total current drawn from the cell, and so this current 2 ampere will be divided in the two arms of the resistances given between A and B. Since these two resistances are equal, therefore the current should also be equally passing through them. So that means each arm of 4 ohm is carrying 1 ampere, is having 1 ampere current through it, passing through it. We can also find it by using the concept that the potential drop across any given pair of points is always same. and therefore current through the first arm say I1 into its resistance equal to current through the second arm into its resistance, and so that becomes I1 into 4 equal to I2 into 4, and since 4 are common on both sides, so we have I1 is equal to I2, and also I1 plus I2 is equal to 2 ampere. Therefore we can easily find that I1 is equal to I2 is equal to 1 ampere. So this is for the resistances lying between the points A and B. But when we speak about current passing through the resistances between point C and D, we can apply it in the same way, but in this case the currents are not same, because the resistances between CD in this parallel combination are different. One arm is having 12 ohm and another arm is having 6 ohm. So if the current passing through the upper arm of the CD resistance is say I3, and for lower arm it is the I4 current passing through the lower arm 6 ohm, then we have I3 into 12 equal to I4 into 6. So you can see here I3 into 12 is equal to I4 into 6, and therefore we have I4 is equal to 2I3. But we also know the fact that total current drawn is equal to 2 ampere by these two resistances together, and therefore having these two relations, I4 is equal to 2I3 and I3 plus I4 is equal to 2 ampere, and therefore on solving this we get I3 is equal to 2 by 3A and I4 is equal to 4 by 3A, ampere. And that how we have solved it. We have solved it by using the method of simultaneous equations, solving simultaneous equations. So this is how we got the current passing through each arm of the resistances between point C and D, and others 1 ohm above and below, both are having the same current 2 ampere passing through them. And that way we have calculated this, we have done the B part. Now we speak about the C part, in which it is being asked that obtain the voltage drop across AB, BC and CD. You know that voltage drop is given by using the relation V is equal to IR. Using the relation V is equal to IR, we can have the potential drop across AB is equal to current through each and either of the arm and resistance of that arm. So that becomes I1 into 4, and that is 1 ampere into 4, that is 4 volt. So 4 volt potential drop is taking place across point AB, and then across point BC we can have 1 ohm is their resistance between BC. Current of 2 ampere is passing through it, therefore potential drop across BC will be 2 into 1 ohm. And finally the potential drop across CD can be also calculated in same way. We know the current passing through the resistance 12 ohm is 2 by 3 ampere, as we have already done here, and then multiplying it with 12, so that becomes 2 by 3 into 12, and that becomes 8 volt. This is the potential difference across CD. We can also find it by using the other method, taking the equivalent resistance of the combination of 12 ohm and 6 ohm, and then multiplying with the total current drawn by the wire. So that becomes 4 into 2, that is 8 volt. So either way we get the same result. Now when we add the potential drops across each arm, that is 4 volt, 2 volt and 8 volt, it becomes 14 volt only. Thus the terminal voltage of the battery will show only 14 volt. But what has happened to the remaining 2 volt of the battery? This is accounted by the internal resistance potential drop due to an internal resistance within the cell. And so you see the internal resistance of battery is 1 ohm, and that multiplied by 2 ampere becomes 2 volts. So the total 16 volt of the cell is now being accounted. 14 volt is dropped outside the cell. So when we measure this potential difference across the terminals of the cell, we get 14 volt reading, where and the 2 volt potential drop is taking place inside the cell. Thank you and have a nice day.